Hello everyone, welcome back to the channel. Before we start our class, I want to show you a video about battery.
I have a huge family. There are many types of batteries. We had a family reunion recently for my grandma's birthday.
Oh!
Yeah, I have some pictures. There's all my brothers, sisters, and me. We're the AA4. We were born in a 4-pack.
Wow!
Yeah, it's tough to stand out when there's so many of us and we all look the same.
I see.
Oh, look, these are my cousins, the AAA triplet. They're tinier than my siblings and me.
Aw, how cute!
Yeah, they're cute, but not as cute as my second cousins, the button cell baby batteries.
Adorable!
Yeah, they were a hit at the family BBQ.
Barbecue? What do batteries eat?
Nothing. Oh, look here, there's Uncle 9-Volt.
Oh, wow! Your Uncle 9-Volt has both his plus and minus ends on the top.
That's right, we're all a little different.
Yes, you all come in different shapes and sizes.
That's right, AAA, AA, button cell, CD, 9-Volt, and we can't forget my Grandma car battery. We all love Grandma car battery.
Yes, there are a lot of size and shape of the battery. Right now, if you can find some batteries around you, try to see the label. In the label, did you see any value like this? For example, 4.5 volt, 6 volt, 9 volt, or maybe 12 volt. So what the value indicates for? Actually, this value indicates for the electromotive force of the battery. Means each battery has a different electromotive force. What is the electromotive force? That's what we will learn today. So, for the topic of electric, today we will learn the subtopic of electromotive force and internal resistance. There are 3 learning outcomes that you must know. So, at the end of this video, you must be able to define electromotive force. We can write it as EMF. Second, you must be able to explain internal resistance. We also can write it as small r. Third, you must be able to solve the problems involving EMF and internal resistance in a dry cell. Dry cell is also known as battery. Let's start with electromotive force. Electromotive force or EMF is defined as work done by an electrical source to move 1 coulomb of charge in a closed circuit. And the unit for electromotive force is volt. Did you still remember what we learned before about potential difference? It almost same with this type of electromotive force. Okay, let's recap what is potential difference. We call it as V. It is defined as work done to move 1 coulomb passes between 2 points. And the unit also same like electromotive force, which is volt. Yes, electromotive force and potential difference almost same. So now let we see what the difference between them. Look at this picture. This is open circuit. It means the switch in the circuit is off. As we can see, there are emitters here. The function of emitter is giving the value of current. So, since the switch in the circuit is off, there are no current flow. And when there are no current flow, means the emitter reading has no value. And in this case, the voltmeter reading is giving you the EMF value of the battery. Now, look at this closed circuit. As we can see in the picture, the switch in the circuit is on. Means there are a current flow through all the circuit. So, the emitter reading will give you the value of the current flow. And here, the voltmeter reading will give you the potential difference of the circuit. Now you see what the difference between EMF and potential difference. In closed circuit, you can see the voltage drop caused by the internal resistance. What is the internal resistance? Let's move to the internal resistance. Let's recap first. What is the external resistance that we had learned before? In Ohm's law, the external resistance means the opposition to the flow of current offered by any load. Normally, external resistance comes from outside of the source. Look at this picture. The external resistance in this case comes from the resistor. Meanwhile, internal resistance means the opposition to the flow of current due to the electrolyte in the battery. The electrolyte means here the chemical in the battery. And normally, internal resistance located inside of the source. It will cause energy to be lost from the battery, for example, as heat. As we can see in this picture, the internal resistance was in the battery. Now, let's look what the effect of internal resistance on voltage drop. Here is the formula. As we know, if the current flow through all the circuit and we also has the internal resistance in the battery, so the electromotive force in the battery will reduce by the potential difference, and this is what we call the voltage drop, which is E minus V. If we rearrange the formula, we will get E is equal to V plus IR. And the V, which is potential difference, is also known as Ohm's law, which is V is equal to IR. And then we will get E is equal to I multiplied by the sum of external resistance plus internal resistance. Now, let's try your understanding. Ready? Okay, question 1. Diagram shows a dry cell connected to a bulb and the current flow through it is 0.5 ampere. What is the potential difference across the bulb? A. 4.1 volt, B. 8.8 volt, C. 9.0 volt, D. 9.2 volt. Got the answer? Let's discuss. In this case, we are use the formula of E is equal to V minus IR. When we put in the value into the formula, we will get the potential difference across the bulb is 9.2 volt. So, the answer here is D. Now, let's move on to the question 2. Diagram shows an electric circuit. When the switch is off, the voltmeter reading is 9.0 volt. The internal resistance of the cell is 1 ohm. And the question, what is the ammeter reading when the switch is on? Is it A 3.0 ampere, B 3.5 ampere, C 4.0 ampere, or D 4.5 ampere? So, got your answer? Let's discuss. The question mentioned that when the switch is off, the voltmeter reading is 9.0 volt. So, 9.0 volt here means the electromotive force of the battery. In this case, we are using the formula of E is equal to I multiplied by the sum of external resistance and internal resistance. So, when we put the value into the formula, we will get the ammeter reading when the switch is on is 3.0 ampere. And here, the answer is A. Last question, question 3. Diagram shows a circuit. Meanwhile, the graph shows how the potential difference varies with current in circuit. Based on the graph shown, determine the EMF of battery and determine the internal resistance of battery. So how to determine the EMF of battery? Let me see the solution here. This is the formula that we use, which is the formula of electromotive force. When we rearrange, we will get V is equal to negative IR plus E. Then, try to compare with the equation of straight line. We will find out that electromotive force is equal to the intercept on the y-axis. Look at the graph here. The intercept on the y-axis is 2.0. So, we can conclude that the EMF of the battery E is equal to 2.0 volt. Last but not least, how to determine the internal resistance of battery? So, here the solution is. This is the formula of electromotive force that we used just now. When we compare to the equation of straight line, y is equal to mx plus c, we can see that the internal resistance of battery is equivalent to the gradient of graph. What the formula gradient of graph? It is m is equal to y2 minus y1 divided by x2 minus x1. According to the graph given, when we put the value into the formula, we will get gradient of the graph is equal to negative 0.4 ohm. Then, from the comparison that we do just now, m is equal to negative r. So, the final answer here for the internal resistance of battery R is equal to 0.4 ohm. So far, that's all for today. So I would like to thank all of you for watching this video. I hope we will see you again. Bye.